All right. Welcome in, everybody, to another deep dive with us.
I am so excited.
Yeah, this one's pretty cool. I'm excited, too.
Yeah.
Today, we're going to be looking at a firsthand account of a sunrise. And I mean that kind of broadly because it's not your typical sunrise.
Right.
And we have video footage of this. And let me tell you, the source's reactions alone are worth a listen.
I love it when we have a video, like a firsthand account like this, because you really get to see the world through someone else's eyes.
Yeah.
Especially when they're witnessing something out of the ordinary,
Yeah.
You get a glimpse into their thought process as they try to make sense of it all.
Absolutely. So picture this. You're outside. It's early morning. The sun hasn't even come up yet.
Yeah.
And our source is filming. And the first thing they capture are these strange rays shooting upwards in the east. But here's the thing. They seem to be bending along the horizon.
That right there, that's a clue that something interesting is happening with the way light is behaving.
Right.
It makes me think about how temperature inversions can occur near the horizon, especially at sunrise and sunset. You have cooler air near the ground and warmer air above it, and that can cause light to refract in unusual ways.
So like a mirage.
Exactly. A great analogy.
Okay.
When you see those shimmering pools of water on a hot road, it's the same principle. Light bending through layers of air at different temperatures.
So you're saying these rays could be a similar effect?
It's definitely a possibility. We'd need more information about the specific atmospheric conditions that morning to say for sure.
Yeah.
But it's a good working hypothesis.
Okay. So we've got bending rays.
Uh-huh.
But then it gets even weirder. The source turns the camera toward the moon, and they're totally confused. They even say the moon is being lit from above, but the sun isn't up yet.
Now that's intriguing. It could be a matter of perspective and the moon's phase at the time. What's also interesting is the concept of earthshine.
Earthshine.
Even before the sun rises, its light can be scattered by the Earth's atmosphere and then reflected back onto the moon.
So the moon could be reflecting sunlight that's already illuminating the upper atmosphere.
Precisely. It's a subtle effect, but it can make the moon appear lit from above even though the sun is still below the horizon. And the moon's phase would play a role too, with fuller moon being more likely to reflect that earthshine.
Wow, I never knew that.
Yeah.
Okay, but things are about to get really strange.
Mm-hmm.
The source keeps filming, and suddenly they exclaim, "Oh my God, oh my God, you guys look at the split sky!" It's like they're seeing a line, a clear division cutting right across the sky. They try to capture the whole thing on camera, but it seems so vast it's hard to get it all in the frame.
A split sky, huh? That brings up a few possibilities. It could be a shadow effect from a distant cloud formation, or perhaps it's related to the way light is being scattered and refracted in different atmospheric layers.
Right, and then they say something even more bizarre, so I guess the dome is broken. They're connecting the split sky to the idea of, well, something like a barrier being disrupted. It seems like they're trying to fit what they're seeing into some kind of framework they already have in their mind.
That's where things get really fascinating. The concept of a dome over the Earth often comes up in certain worldviews and belief systems. It's a powerful image, and it seems to be influencing how the source is interpreting this unusual sky.
It really shows how our pre-existing beliefs can shape how we understand the world around us, especially when we're confronted with something we can't immediately explain.
Absolutely.
Yeah.
And that makes me wonder, what else did they observe as this unusual sunrise unfolded?
Well, next they mention being completely in awe, even though they claim to have seen this split sky before. They even compare its size to the moon panning the camera to emphasize how much of the sky it covers.
They've seen it before. That suggests it might not be a completely random occurrence. It could be linked to specific weather patterns or seasonal changes that create the right conditions for this split sky phenomenon.
Makes you wonder how many times we've all just glanced at the sky and missed something amazing because we weren't really paying attention.
Certainly does.
Yeah.
But wait, you said there's more to this video.
Oh, yeah.
What else did our sunrise observer capture?
Get this. They point out a cloud nearby that's actually glowing, even though the sun is still below the horizon. And they're just blown away by it all. I mean, everywhere they look, there's something strange happening in the sky.
A glowing cloud before sunrise. That's interesting. It could be something as simple as early sunlight hitting high-altitude clouds and scattering the light. We often see that in places with expansive views of the horizon, where the sun's rays can reach those high clouds even before it's visible to us on the ground.
Makes sense. And then just like that, the video ends. They have to go get their kids ready for school, but they leave us with this one last thought. They only know one other person who's ever captured this kind of split sky on video.
That's quite a cliffhanger. It really makes you wonder how common these kinds of visual anomalies are. Is it just that most people don't notice them? Or are they truly rare events? And if they're connected to specific atmospheric conditions, where are they most likely to occur?
So many questions. But before we go down that rabbit hole, maybe we should take a step back and really unpack those initial observations. I'm especially curious about those bending rays and what might have caused them.
Let's do it. I think there's a lot more to uncover here. Those bending rays are a great place to start. They really highlight how light can behave in unexpected ways, especially when you have these distinct layers of air at different temperatures. It's not just about warm and cold air, though.
Right.
The density of the air also plays a role.
Okay, so how does air density fit into all of this?
Think of it this way. Light travels faster through less dense air. So when light passes from a denser layer of air to a less dense layer, it bends away from what's called the normal, an imaginary line perpendicular to the boundary between the two layers.
Gotcha. So if you have those temperature inversions we were talking about, where the cooler, denser air is near the ground and the warmer, less dense air is above it,
Right.
light coming from the horizon would bend upwards as it passes into that less dense air.
Exactly. And that upward bending could be what creates the illusion of those rays shooting up and curving along the horizon. It's like the light is taking a curved path through the atmosphere because of those density gradients.
That's wild. It's like a natural lensing effect. But then how does that tie into the split sky the source observed? I feel like those two phenomena would have to be related somehow.
I think you're onto something there. If we're already seeing evidence of light being bent and distorted by these atmospheric conditions, it's not a stretch to think those same conditions could be contributing to that stark visual separation in the sky.
So we might be looking at a scenario where different layers of air are not only bending the light, but also scattering it differently.
Precisely. Different wavelengths of light scatter differently depending on the size and type of particles in the air. So you could have a situation where one part of the sky appears darker or a different color because the light is being scattered away more effectively in that region.
So it's not necessarily a physical split, but rather a visual effect created by the way light is interacting with the atmosphere.
That's the beauty of optics. What we see isn't always a direct representation of what's physically there. It's filtered through this complex interplay of light and atmospheric conditions.
Makes sense. Okay, but what about the moon? We were talking about Earthshine before, but I'm still not totally sold. That explains why the source thought the moon was lit from above. It just seems so counterintuitive.
I hear you. It's one of those things that can really challenge our understanding of how celestial objects appear from our earthly perspective. Let's break it down a bit further.
Please do, because I'm definitely still trying to wrap my head around it.
First, remember that even though the sun is below the horizon, its light can still reach the upper atmosphere. And that's where Rayleigh scattering comes into play.
Rayleigh scattering.
It's the reason why the sky appears blue during the day. Essentially, shorter wavelengths of light, like blue and violet, are scattered more effectively by the tiny particles in the atmosphere. So even before the sun rises, those scattered blue and violet wavelengths can illuminate the upper atmosphere.
Okay, I'm with you so far.
Now imagine that scattered light illuminating the moon from above. Depending on the moon's phase, the angle of the sunlight hitting it, and the observer's position on Earth, it's entirely possible to perceive the moon as being lit from above, even though the sun itself hasn't risen.
It's like an optical illusion on a grand scale.
Exactly. And it just goes to show that even something as familiar as the moon can appear differently depending on the circumstances. But let's not forget about that dome concept the source mentioned. I think that deserves a closer look.
Yeah, I agree. It seems like they were trying to reconcile this unusual sky with their existing beliefs. But what exactly is it about a split sky that would make someone think of a dome?
Well, the idea of a dome over the Earth has been around for centuries.
Right.
It pops up in various cultures, mythologies. Sometimes it's a physical barrier. Other times it's more of a metaphorical concept. But it often represents a separation between our world and something else, the heavens, the cosmos, the divine.
So when the source sees this split in the sky, it's almost like they're interpreting it as a break or a tear in that dome.
That's a very astute observation. It's like they're seeing a visual representation of something that already exists in their mind, this concept of a dome being disrupted.
It makes me wonder if they would have even interpreted it that way if they hadn't already had that belief in place.
That's a great question, and it really gets to the heart of how our perceptions are shaped by our prior knowledge and experiences.
Yeah.
We don't come to the world as blank slates. We're constantly filtering information through the lens of what we already know and believe.
It's like our brains are trying to make sense of new information by fitting it into existing categories, and sometimes those categories might not be entirely accurate or complete.
Exactly. And that's why it's so important to be open to new information, to question our assumptions, and to be willing to revise our understanding of the world as we learn more.
It's a reminder that learning is an ongoing process.
Yes,
We're never really done.
couldn't agree more. But there's still more to explore in this sunrise account.
Okay.
What about that glowing cloud the source mentioned? I'm
Yes.
curious to delve into that a bit further.
Right. They were so surprised to see it because the sun was still below the horizon. Let's talk about what might have caused that.
Yeah, it was pretty striking imagery, like a glowing cloud against a dark sky and the sun still down below the horizon. I have to admit, it does make me wonder if there's more to it than just early sunlight hitting high-altitude clouds.
It's certainly a possibility worth considering. After all, we've already seen how much complexity there can be in the way light interacts with the atmosphere. What if this glowing cloud is tied to some of those same principles of refraction and scattering?
Okay, I like where you're going with this.
Okay, so imagine those same temperature inversions we discussed earlier.
Right.
Cooler, denser air near the ground, warmer air above it. Now imagine a cloud positioned right at that boundary layer between those two air masses.
Okay, I can picture it.
Now think about how light from the rising sun would pass through that layered atmosphere. It could refract through those different air densities in a way that focuses and concentrates the light onto that particular cloud. Oh, wow. So instead of just scattering the light, the atmosphere might be acting like a lens amplifying the sun's rays onto that cloud, even though we can't see the sun directly yet.
Exactly. It's a fascinating possibility, and it would explain why the source was so struck by the cloud's intense glow.
It's incredible how much is happening in the sky that we often miss because we're not looking closely enough. I mean, think about how many sunrises and sunsets we've all seen and never noticed these kinds of details.
It's a reminder that the world is full of hidden wonders waiting to be discovered. All it takes is a little curiosity and a willingness to pay attention.
And maybe a camera too, right? So
Yeah.
we can capture those fleeting moments and revisit them later.
Right.
Because I have a feeling that even with all the analysis we've done, there are still layers to this sunrise event that we haven't uncovered.
Absolutely. This deep dive has raised more questions than it's answered. It's a reminder that there's always more to learn, more to explore. And that's the beauty of science. It's a journey, not a destination.
Yeah, and it's a journey that anyone can take. You don't need a lab coat or a fancy degree to be a scientist. All you need is that spark of curiosity and a willingness to observe the world around you with open eyes.
And maybe a good cup of coffee to help fuel those early morning observations.
Right. Speaking of which, I think I hear mine calling.
Mine too. But before we sign off, I want to leave our listener with a thought to ponder. What if this split sky phenomenon is more common than we realize? What if it's happening all the time, but most of us are simply too busy or distracted to notice?
It's a challenge to all of us to look up a little more often, to pay attention to the subtle cues and patterns in the world around us, because you never know when you might stumble upon something truly extraordinary.
The sky's the limit.
Well said. And on that note, we'll wrap up this deep dive. Thanks for joining us, and until next time, keep exploring.